Somewhere in the ancient world, a physician looked at a patient whose eyes had grown dim with age and reached not for a blade or a compound of minerals, but for a fruit. A specific fruit, one that required no preparation, no prescription, no explanation beyond. Eat this, and eat it often. We call that instinct primitive. We have clinical trials now. We have randomized controlled studies and peer-reviewed journals and optometry departments with instruments that can photograph the back of your eye in extraordinary detail. And yet, and here is the thing that keeps drawing researchers back, the fruits those ancient physicians reached for keep appearing in the data, not as curiosities, as answers. Today, we are going to look at 13 fruits that modern research consistently associates with protecting and supporting vision after 60. And the science behind why these particular fruits matter is not vague or theoretical. It is specific. It is tied to a precise part of your eye, one most people have never heard of, that does something irreplaceable. Something no surgery can restore once it is gone. Pay close attention to number 1. Most people walk past it in the produce aisle every single week. It is not exotic. It is not expensive. And what it does inside the macula, the exact tissue most vulnerable to age-related damage, is some of the most carefully documented nutritional science in the field of preventive ophthalmology. But before we reach number 1, I need to tell you about number 7 on this list. Because tied to that fruit is a story from the ancient world, a story of survival in the desert, of a man left for dead, and of a food that brought him back from the edge. It is not allegory. The physiological mechanism is real, and when you understand what that food does at the cellular level, you will understand why it was carried by soldiers, healers, and traveling merchants across 3 continents for thousands of years. Let us start with what is actually happening inside your aging eye. Number 13. Papaya. The Ebers Papyrus, compiled around 1550 BCE and considered one of the oldest surviving medical texts, includes references to the use of papaya pulp for conditions affecting vision and inflammation. Ancient Egyptian physicians noted its specific usefulness for the eyes, though they could not have named why. Traditional Ayurvedic medicine also cataloged papaya under its classification for pitta-related imbalances, the fire element governing inflammation and visual clarity. Independently, pre-Columbian Mesoamerican healers used the fruit, which they called chichi-waltzapatl, for wounds and systemic healing. 3 traditions. 1 fruit. The same application. Modern phytochemical analysis reveals what they were responding to intuitively. Papaya is one of the richest dietary sources of beta-cryptoxanthin, a carotenoid that the body converts to vitamin A, essential for the production of rhodopsin, the pigment your rod cells use to see in low light. 1 medium papaya delivers more than 100% of your daily vitamin A requirement. It also provides meaningful quantities of lycopene typically associated with tomatoes, but present in ripe red papaya at concentrations that researchers at the University of Hawaii found comparable or superior, lycopene has shown. In clinical studies, an affinity for protecting ocular tissue from ultraviolet oxidative damage. For practical use, ripe papaya, eaten raw rather than cooked, preserves these carotenoids intact. Add a squeeze of lime. The citric acid appears to enhance stability of the pigments during digestion. A serving roughly the size of your fist, 3 or 4 mornings a week, gives you a consistent carotenoid contribution your aging retina will draw on. The ancient physicians who reached for papaya were not guessing. They were noticing. Across thousands of years of careful observation, they reached the same conclusion the laboratory is now confirming. Number 12. Pomegranate. In the Hebrew scriptures, the pomegranate appears more than 30 times. It was woven into the hem of the priestly garment in Exodus. It decorated the pillars of Solomon's temple. It was carried by the spies sent into Canaan as evidence of the land's abundance. This was not ornamental prominence. In ancient Near Eastern culture, a fruit, given that level of symbolic weight, was a food of medicinal and nutritional consequence. Persian and Greco-Roman physicians Dioscorides wrote of it in De Materia Medica. The pharmacological reference text that shaped Western medicine for 15 centuries noted pomegranate's capacity to reduce inflammation in the vessels and membranes of the body. The active compounds explain why. Pomegranate seeds and juice contain punicalagins, polyphenols, so potent that pomegranate juice has been measured in multiple studies as having 2 to 3 times the antioxidant capacity of red wine or green tea by standard ORAC measurement. More relevant for vision, punicalagins break down in the body to produce urolithins, compounds that research from the Salk Institute has linked to improved mitochondrial function in aging cells, including retinal cells, which depend on mitochondrial efficiency to maintain their extraordinary energy demands. One critical detail, almost never mentioned, the white pith inside the pomegranate, the bitter membrane, most people discard, contains concentrated levels of these polyphenols. Traditional Middle Eastern preparation often included the pith in pomegranate juice. Modern commercial juicing removes it entirely. Eat the arils, the jewel-like seeds whole. Press them into a small glass of juice that retains the pulp, or simply chew a quarter of a pomegranate as you would any fruit. The punicalagins require the full fruit matrix to deliver their full effect. Civilizations that knew nothing of oxidative stress wrote this fruit into their most sacred texts. The biochemistry is now catching up to what they already believed. Number 11. Mango. The Charaka Samhita. The foundational Ayurvedic medical text, compiled between 600 BCE and 200 CE, describes mango as a food for chakshu literally, the eyes. It was prescribed specifically for conditions of dryness, heat, and dimming of sight. Simultaneously, traditional Chinese medicine categorized mango as a food that nourishes the liver, understood in TCM to be directly connected to the health of the eyes through the liverwood element governing visual clarity. Mango's primary contribution to eye health is its exceptional zeaxanthin content, the second of the 2 critical macular pigments. While most carotenoid conversations focus on lutein, zeaxanthin is what concentrates most densely at the very center of the macula, the fovea, the single point, responsible for the sharpest possible visual resolution. Ripe mango provides roughly 0.5 milligrams of zeaxanthin per 100 grams, alongside beta-carotene and cryptoxanthin that the body can convert to active vitamin A. Here is the preparation detail that matters. Zeaxanthin, like lutein, is fat-soluble. Eating mango with a small amount of fat, a tablespoon of full-fat yogurt, a few slices of avocado, even a small handful of nuts can increase zeaxanthin absorption by a factor of 3 to 4 compared to eating the fruit alone. This is not a minor variation. It is the difference between feeding your fovea and simply passing the nutrient through ripe mango, eaten at room temperature rather than cold from the refrigerator. Presents its enzymes in a more active state. A slice or two at lunch, 3 or 4 times a week, paired with something containing fat, makes this an effortless addition to a vision protective diet. 2 traditions, separated by thousands of miles, place the same fruit in the same category. The mechanism is now understood. The practice still holds. Number 10. Grapes dark, red varieties. The vine. No food in the Hebrew scriptures carries more layered significance. Noah planted a vineyard after the flood. The promised land was described through a cluster of grapes so large it required 2 men to carry it on a pole. In the Psalms, the vine is a metaphor for abundance and health. And in the New Testament, wine pressed from the grape becomes the most sacred element in Christian liturgy. A fruit given that weight of meaning across that span of time was not merely ceremonial. Greek physicians documented the use of grape leaves, an unfermented grape, must the pressed juice before fermentation, for eye inflammation and weakness of sight. Medieval European monastic medicine, transmitted through the texts of Hildegard von Bingen, specified dark grapes for conditions affecting the head and the senses, including vision. What the research identifies is resveratrol concentrated in the skin and seeds of dark grapes, which has shown in laboratory studies the capacity to inhibit abnormal blood vessel growth in the retina, Abnormal retinal vascularization is one of the key mechanisms in advanced wet macular degeneration and in diabetic retinopathy. Additionally, the oligomeric proanthocyanins, OPCs found in grape seeds, have been studied in Japan and France for their effect on retinal microcirculation, with results that sustained enough interest for several commercial preparations of grapeseed extract to emerge from that research. Practical note: eat the skins. The resveratrol concentration is dramatically higher in the skin than the flesh. Concord grapes, the dark, almost purple American variety, contain among the highest resveratrol levels of any common table grape. A small bunch, perhaps 20 to 25 grapes, 3 or 4 times a week, with skins intact, contributes meaningfully to retinal vascular protection. Thousands of years of reverence for this fruit. The laboratory is still mapping the reasons. Number 9. Fig. Figs appear in Scripture with specific medicinal intent. In 2 Kings, chapter 20, verse 7, the prophet Isaiah prescribes a poultice of figs for King Hezekiah's illness, an external application of concentrated fig paste to an infected wound. This is not incidental. Ancient Near Eastern medicine understood that figs contained something biologically active. Simultaneously, traditional Chinese medicine listed figs, wu hua guo, as a food for clearing heat from the liver and brightening the eyes. Arab physicians of the medieval Islamic Golden Age wrote of the fig's specific effect on the eyes and the vessels that feed them. This convergence, Hebrew scripture, zeaxanthin, Islamic medicine, across cultures that had no exchange of texts on this specific point, is itself significant. Figs contain a unique flavonoid profile, including quercetin and kaempferol, both of which have shown, in laboratory and animal studies, the capacity to protect retinal ganglion cells, the cells whose axons form the optic nerve from apoptosis, programmed cell death under conditions of elevated intraocular pressure. Early research from Tufts University identified figs among a small category of fruits with the highest total phenolic content per serving. The preparation detail few people discuss. Dried figs concentrate these phenolics to approximately 3 times the density of fresh figs by weight. 2 dried figs provide a meaningful phenolic dose. But the drying must be unsulfured. The sulfur dioxide used to preserve the golden color of commercial dried figs significantly degrades quercetin. Look for dark brown dried figs. The color indicates the phenolics are intact. Isaiah reached for figs when a king's life was at stake. The chemistry suggests he was drawing on knowledge accumulated over generations of observation. Number 8. Apricot. Apricots are mentioned in traditional Chinese medical texts as early as the Han Dynasty, where the kernel, the seed inside the pit, was classified as a medicine for the lungs and, by the 5-element correspondence, for conditions of dryness affecting the eyes. Concurrently, ancient Persian medicine, which formed the bridge between Greek medical tradition and Islamic scholarship, held apricots as a specific restorative for vision weakened by heat and age. The beta-carotene content of apricots is exceptional, among the highest of any common stone fruit. But the eye-specific compound in apricots that rarely receives attention is beta-cryptoxanthin, the same carotenoid found in papaya, which the body converts to retinol active vitamin A. The cornea, the clear dome at the front of your eye, requires consistent vitamin A to maintain its transparency and moisture. Vitamin A deficiency, even subclinical deficiency, is associated with dry eye, increased susceptibility to infection, and in advanced cases, corneal clouding. A study published in the Archives of Ophthalmology found that higher total carotenoid intake with beta-carotene as a significant component was associated with a 43% lower risk of neovascular AMD compared to the lowest carotenoid intake group. Apricots were among the carotenoid-dense foods identified in the dietary recall data of the high-intake group. Practical specificity. Dried apricots deliver concentrated beta-carotene, but as with figs, choose the dark, unsulfured variety rather than the bright orange sulfured version. 4 to 6 dried apricots provide a meaningful carotenoid contribution, or 2 to 3 fresh apricots in season, eaten with a small amount of fat for absorption. Persian physicians prescribed this fruit for aging eyes more than 1,000 years ago. The mechanism they were responding to has now been measured in randomized trials. Number 7. Dates. He was exhausted. 3 days in the desert without water. He had collapsed. The text says he could not eat, could not drink, could not stand. The soldiers who found him expected to carry a corpse. 1 Samuel, chapter 30. David and his men, returning from battle, came across an Egyptian servant abandoned by his master, left in the desert to die. They gave him water. They gave him a piece of fig cake. And then the text is specific. They gave him 2 clusters of raisins and dates. And the scripture records his spirit revived. He recovered enough to stand, to speak, to lead David's men to a hidden camp that changed the outcome of the battle. That is not just poetry. That is a description of metabolic restoration. The human body in severe physical collapse requires 3 things, almost simultaneously: rapid glucose for neural and cardiac function, potassium to restore cellular electrolyte balance, and iron to support oxygen transport in blood that has been depleted by exertion. Dates deliver all 3 in precise combination. A single medjool date contains approximately 18 grams of natural sugars in a form the body absorbs without significant insulin spike. 167 milligrams of potassium, more than a banana of equivalent weight, and a meaningful contribution of iron per serving. But for vision, specifically, dates are one of the few fruits that contain meaningful lutein and zeaxanthin in dried form. Most drying processes degrade these carotenoids significantly. Dates, owing to their low water activity and natural sugar matrix, preserve lutein at levels that remain measurable after drying. A 2020 analysis published in Food Chemistry confirmed lutein and zeaxanthin presence in multiple date varieties, with the medjool variety showing the highest retention. Additionally, dates contain polyphenols including ferulic acid and protocatechuic acid that have shown, in laboratory models, the capacity to protect retinal pigment epithelial cells from oxidative damage. The retinal pigment epithelium is the cell layer directly beneath your photoreceptors. It is what you are really trying to protect when you talk about slowing macular degeneration. 2 dates, eaten daily, alongside a source of fat to support carotenoid absorption. This is an ancient prescription. It is now a measurable one. The Egyptian servant revived in the desert. The mechanism of his recovery was not miraculous. It was biochemical. And those who carried dates on their journeys were carrying medicine they understood through centuries of witnessed results. If the history inside these fruits is speaking to you, if you are realizing that what grows from the earth has always known what the body needs, hit like right now and subscribe. What comes next gets even more specific. And the number 1 fruit on this list connects ancient practice to one of the most carefully documented pieces of nutritional science in modern ophthalmology. Number 6. Goji berries. Goji berries, Lycium barbarum, have been described in Chinese medical texts for more than 2,000 years. The Binchao Gangmu. The Great Ming Dynasty Pharmacopoeia, compiled by Li Shizhen in 1578, described goji as a tonic for the liver and the eyes, noting their specific utility for conditions of visual dimming and night blindness in older individuals. This was not a casual inclusion. Li Shizhen dedicated more precise clinical detail to goji than to most other entries, in a text covering nearly 1,900 substances. Goji's eye health reputation is now among the most scientifically examined of any traditional Chinese botanical. Zeaxanthin dipalmitate, the specific esterified form of zeaxanthin found in goji berries, is the dominant carotenoid in goji, and it concentrates with remarkable precision in the macula. A 2011 randomized controlled trial published in Optometry and Vision Science followed older adults who consumed a daily milk-based goji beverage for 90 days. Compared to controls, the goji group showed significant protection against macular pigment loss and showed less accumulation of drusen, the lipid deposits in the macula that are the earliest measurable sign of age-related macular degeneration. The esterified form of zeaxanthin in Goji requires saponification, essentially the action of bile acids in the digestive tract before it can be absorbed. This process is enhanced by the presence of dietary fat, a tablespoon of dried goji berries, soaked in warm water for 10 minutes to rehydrate the cell walls and improve bioavailability. Then added to a meal containing fat, provides a meaningful zeaxanthin dose in a form optimized for absorption. 2,000 years of Chinese clinical observation directed physicians to this berry for aging eyes. The controlled trial confirmed they were right, down to the specific mechanism. Number 5. Bilberry. Bilberry Vaccinium myrtillus entered modern clinical awareness under unusual circumstances. During the Second World War, British Royal Air Force pilots reportedly consumed bilberry jam before night missions. With the claim that it improved their night vision, the military account is imprecise. As such, accounts often are, but it was enough to launch decades of research that eventually produced some of the most specific data on any fruit and visual function. The historical record is older and more careful than the wartime story. Hildegard von Bingen, the 12th century Benedictine abbess and natural philosopher, whose medical writings were drawn from centuries of monastic botanical practice, wrote of bilberry in her pharmacological text Physica as a food for strengthening the sight. She was drawing on a tradition of Northern European herbal knowledge that had been accumulating since at least the early medieval period. Bilberry's active compounds are anthocyanins, specifically a complex of 15 distinct anthocyanin glycosides, a diversity not found in any other common berry, including blueberry. These compounds have shown, in laboratory and clinical research, the capacity to regenerate rhodopsin, the visual pigment in rod cells, responsible for night vision, at a faster rate than would occur without supplementation. A study published in the Journal of Ocular Pharmacology and Therapeutics found that bilberry extract improved contrast sensitivity and glare recovery time in subjects with myopia. Glare recovery, how quickly your vision clears after exposure to a bright light, is one of the first visual functions to decline with age, and it is driven precisely by the rate of rhodopsin regeneration. Fresh bilberries are difficult to source outside of Northern Europe. Dried bilberries or high-quality bilberry preserves without added sugar are the most practical form. 2 tablespoons of dried bilberries, or a quality bilberry extract, standardized to 25% anthocyanins, 3 to 4 times a week. The anthocyanins concentrate in the fruit skins, so whole berries, rather than juice, deliver the full profile. Medieval monastic physicians charted what pilots noticed in wartime, and the laboratory eventually explained it in the language of rhodopsin kinetics. Number 4. Blueberry. Blueberries do not appear in biblical texts. They are native to North America and unknown to the ancient Near East, but they appear prominently in the traditional botanical knowledge of multiple indigenous peoples of the eastern woodland regions, where they were used as a food medicine for the eyes and for conditions of inflammation and poor wound healing. The Ojibwe people prepared a tea from wild blueberry leaves, specifically for vision. The Haudenosaunee documented their use as a food of strength and restoration. What makes blueberries unique among commonly available fruits is their anthocyanin diversity, combined with their accessibility and studied effect on retinal microcirculation. The small blood vessels feeding the retina are among the most delicate in the human body. They are among the first structures to show damage from elevated blood sugar, hypertension, and inflammatory stress. A 2012 study in the British Journal of Nutrition found that bilberry anthocyanins closely related structurally to those in cultivated blueberries were associated with measurable improvements in retinal microcirculation in subjects who consumed them daily over 4 weeks. Here is the specific detail that matters for older adults. Anthocyanins degrade quickly when heated. Cooking blueberries significantly reduces their anthocyanin content. Frozen blueberries, however, retain close to full anthocyanin density. Freezing actually disrupts the cell walls slightly, which can improve the release of anthocyanins during digestion. A half cup of frozen blueberries, thawed at room temperature and eaten raw, provides a retinally relevant dose of these compounds at a fraction of the cost of fresh, a handful, 4 to 5 mornings a week, thawed from frozen, not cooked, simple, affordable, and the vascular effect on the retina is now measured, not assumed. Indigenous practitioners of the eastern woodlands encoded this knowledge over generations of observation. The studies of the last 2 decades are confirming what was already understood. Number 3. Orange whole fruit. In the Talmud Yerushalmi, the Jerusalem Talmud, compiled between the 3rd and 5th centuries CE, citrus fruit is discussed in the context of healing the body and maintaining the faculties of perception, though the specific mechanisms were not yet named. Roman agricultural writers, including Columella in the 1st century CE, noted the specific esteem in which Mediterranean physicians held citrus for conditions affecting the head and the senses. What the research now shows about whole oranges and vision is specific enough to be worth stating precisely. The lens of your eye, the structure that focuses light onto your retina, contains one of the highest concentrations of vitamin C of any tissue in the human body. It uses that vitamin C to defend its proteins against oxidative damage. When lens proteins oxidize and cross-link, the lens becomes opaque. That is a cataract. The age-related eye disease study, AIRD's the landmark National Eye Institute trial, identified vitamin C as one of the 4 nutrients specifically associated with reduced risk of cataract progression. A single medium orange provides approximately 70 milligrams of vitamin C, but the key is the whole fruit, not the juice. The white pith, the bitter layer beneath the peel, contains bioflavonoids, specifically hesperidin and naringenin, that work synergistically with vitamin C to protect the small blood vessels of the eye and extend vitamin C's antioxidant activity. In the lens, commercial orange juice removes most of the pith entirely. A glass of juice gives you vitamin C without the bioflavonoid complex that makes it most effective for eye tissue. 1 whole orange daily. Eat the pith. The slightly bitter edge of that inner white layer is the taste of hesperidin, the compound that multiplies vitamin C's protective effect on your lens. The ancient world could not name hesperidin, but they held whole citrus in highest esteem. While discarding nothing, the preparation wisdom was already there. Number 2. Avocado. Avocado appears in Mesoamerican medicinal tradition. The Aztec and Maya peoples cultivated and consumed avocado and documented its uses in the herbal texts collected by Spanish colonial physicians in the 16th century. The Florentine Codex, assembled by Fray Bernardino de Sahagún from indigenous knowledge sources after the conquest, describes the fruit as a food of abundance and vitality used in specific preparations for the health of the eyes and the skin. No other commonly available fruit delivers the combination that avocado does for vision-meaningful lutein content, meaningful zeaxanthin, and uniquely, the monounsaturated fat needed to absorb both. The photoreceptor cells in your retina are wrapped in membranes composed primarily of unsaturated fatty acids, vitamin A, fat-soluble and present in meaningful quantities in avocado, works within those fatty membranes to protect the lipid structure from oxidative degradation, a form of protection that water-soluble antioxidants cannot provide because they cannot enter the lipid environment. The Ohio State University research team published a study in the Journal of Nutrition measuring what happens when avocado is added to a salad alongside other lutein-containing vegetables. The absorption of lutein from the full salad increased by a factor of between 4 and 5 compared to the same salad with a fat-free dressing. That is not a small enhancement. That is the difference between getting meaningful macular pigment support from your meal and extracting almost none. Half an avocado on your lunch salad? 3 to 4 times a week. It is not just providing its own lutein and zeaxanthin. It is unlocking the lutein and zeaxanthin in every other vegetable on that plate. Nothing else in the produce section does both simultaneously. The physicians of the ancient Americas held this fruit as a food of vitality for good reason. The biochemistry explains what their observation already knew. Number 1. Kiwi. There is no ancient text that names kiwi for eye health, The fruit is native to China, where it was called yangtao. The gooseberry of the sheep and its medicinal properties were noted in traditional Chinese botanical literature. Though it remained a regional food until the 20th century, what makes kiwi number one on this list is not the depth of its ancient pedigree. It is the precision of what it does, confirmed by research that is specific enough to be remarkable. A study published in the American Journal of Clinical Nutrition, one of the most cited papers in nutritional ophthalmology, followed adults over a 12-week period. Participants who ate 3 kiwi fruits per day showed a measurable, statistically significant increase in macular pigment optical density, not theoretical, not inferred, measured directly the actual pigment protecting the center of the retina, denser, after 12 weeks of daily kiwi. Why does kiwi accomplish this so specifically? First, lutein. Kiwi contains lutein at approximately 0.1 milligrams per 100 grams, modest by the standards of leafy greens, but in a matrix that appears to make it unusually bioavailable. The food matrix matters enormously. Lutein that the body can actually absorb and deposit into the macula is worth more than 10 times the lutein that passes through unabsorbed. Second, vitamin C. Ounce for ounce. Kiwi delivers more vitamin C than an orange of equivalent size. The lens of your eye uses vitamin C to defend itself against the oxidative damage that leads to cataract formation. This is the same mechanism identified by AREDS, but delivered through a whole food matrix that includes cofactors no supplement replicates. Third, vitamin A. Kiwi contains vitamin E fat-soluble, membrane-active, which protects the fatty envelopes of your rod and cone cells. The photoreceptors that convert light into the signals your brain reads as vision. Lutein for the macula, vitamin C for the lens, vitamin E for the photoreceptors. 3 layers of protection. 3 different parts of the eye. 1 fruit smaller than your fist. Fourth, and this is the detail almost never discussed in mainstream nutrition content, kiwi contains an enzyme called actinidin. This protease is unique to kiwi. Research from New Zealand's Plant and Food Research Institute has shown that actinidin significantly enhances the digestion and absorption of proteins from meals eaten alongside kiwi. This matters because as we age, protein digestion efficiency declines, the stomach produces less acid, digestive enzyme output falls, and the structural proteins your retina needs for maintenance and repair arrive in smaller quantities. Actinidin partially compensates for that decline, improving the overall nutritional yield of any meal that includes kiwi. 2 kiwis daily. 1 with breakfast. 1 as an afternoon snack. Or alongside your salad at lunch, where it will enhance absorption of the lutein in any greens you eat. The skin, though most people discard it, contains concentrated antioxidant flavonoids, if sourced organically. Eating the skin after washing provides a meaningful additional phenolic contribution. There is no ancient civilization that wrote kiwi into its sacred medical canon. What they had instead was millennia of careful observation with other fruits that taught them the pattern that what grows from the earth in its whole, unprocessed form contains something that benefits the body in ways that refinement removes. Kiwi is what the research found when it asked the most specific possible question, which whole fruit most reliably and measurably increases the density of the pigment, protecting the part of your eye most vulnerable to age-related damage. The answer was this small, unremarkable-looking fruit that most people walk past without a second thought. Here is the principle that runs beneath every item we covered today, and it is the one that most people never hear stated directly. Every compound we discussed: lutein, zeaxanthin, anthocyanins, punicalagins, actinidin, hesperidin, zeaxanthin dipalmitate, resveratrol exists in a food matrix, a biological architecture that the plant built over millions of years. The cofactors, the enzymes, the cell wall structures that regulate how these compounds release during digestion. The synergistic interactions between compounds in the same fruit, none of this survives industrial processing intact. When a fruit is pressed into a juice and the pith is discarded, the hesperidin goes with it. When berries are cooked into a jam without regard for temperature, the anthocyanins are degraded. When carotenoids are extracted into supplement form, the food matrix that governs their absorption rate is eliminated. When dried fruit is treated with sulfur dioxide to preserve an appealing color, the quercetin that gave the fruit part of its value is chemically degraded. The ancient world did not process its food for shelf life or visual appeal. It ate what the earth produced in the form it was produced, not because it was philosophically committed to whole foods, but because it had no alternative. And in that absence of alternative, something was preserved that we have spent the last century systematically dismantling. The research we reviewed today is not telling us something new, it is measuring something old. It is quantifying what happened inside bodies that ate differently than we do now. And the consistent finding across study after study, across fruit after fruit, is that the whole food form outperforms the extracted, processed, and refined derivative every time. Your eyes began aging the day you were born. The window for food to make a meaningful difference in what your eyes look like at 75 is not after damage has become visible. The window is now. What will you add to tomorrow's breakfast? Let me know in the comments, and if there is another aspect of natural, evidence-based eye health you want us to dig into next, tell me there too. Someone in your life is thinking about their vision and does not know where to start. Share this with them today. If what we covered here was worth your time, like this video, subscribe, so you are here for the next one. Take care of yourself. Take care of your vision.